class, my name is Ituka Dure Eboko. Welcome to today's lesson. Our lesson is determine intervals where a function is increasing or decreasing. The objective of this lesson, you are expected to 1. State the corollary of mean value theory where it is increasing and decreasing. Secondly, determine intervals when a function is increasing and decreasing. And lastly, construct a variation table to determine intervals when a function is increasing and decreasing. We proceed with our lesson by stating the corollary of mean value theory. The corollary of mean value theory states that let f of x be a continuous function on the closed interval ab and differentiable on an open interval ab, then if the first derivative, that is f prime of x, is less than 0 on each of those open interval ab, then the function f of x is an increasing function on the closed interval ab. Finally, if f prime of x is less than 0 on each of the open interval ab, then the function f of x is a decreasing function on the closed interval ab. The above corollary simply explains to us that if we select a value of x in an interval and evaluate f prime of x in that selected interval, and if f prime of x is greater than 0 on each of those intervals, we conclude that the function is an increasing function. Similarly, it holds for decreasing function. We are now going to proceed with the lesson with an example. Before we have an example, we have to note the following points. Firstly, on the stated corollary, we have to note that the corollary applies for both finite and infinite intervals. Secondly, we have to know that to obtain the intervals when a function is either increasing or decreasing, we find the critical points. The critical points are the values of x for which that function, the first derivative of that function is 0. We use the critical point to span the entire real number line of the possible values of x. We select values of x on each of those intervals and find the sign of f prime of x. And if f prime of x is greater than 0, we conclude from the above corollary. Similarly, it holds for decreasing function. We have to note the next that a variation table is a table that shows intervals on the number line where a function is increasing and decreasing. And finally, we have to note that a function is said to be monotonic if it's always either increasing or always decreasing on its domain of definition. We are going to proceed with an example to demonstrate the monotonicity of a function clearly on its variation table. Consider the function f of x given as x minus x on 3, where f lies from the set of real number to the set of real number defined by this. Now, to determine the monotonicity of that function, the first thing is to look for the first derivative. The first derivative of that function is 1 minus x squared. And we have noted that at the first derivative, to obtain the critical point is being obtained when the first derivative is 0. So at critical point, f prime of x equals 0 implies that 1 minus x squared is 0. Solving for x, we obtain that x is either negative 1 or x is 1. We are now going to span that critical point on the entire real number line, and we observe that the possible intervals are x less than negative 1, or x lies between negative 1 and 1, or x greater than 1. The next thing is to determine where of those intervals the function is either increasing or decreasing. We use the variation table. On the variation table, we span those real number line, x less than negative 1, negative 1 less than x less than 1, and x greater than 1. We observe that evaluating f prime of x at that interval, here it is, we value that less than negative 1 is 8, negative 1 to 1 it is 1, greater than 1 it is negative 8, and we observe that the sign of f prime of x, here at that point, we have taking value that less than negative 1, we have negative 8, between negative 1 and 1 we have 1, value that greater than 1, for example 3, we have negative 8. And what are the signs? Here it will be positive, so here will be negative. Here f prime of x is positive and here f prime of x is negative. What is the conclusion of the function f of x given as x minus x upon 3? Here it is decreasing, here it is increasing, and here it is decreasing. Conclusion, we conclude that from the variation table above, the function f of x is increasing on the interval negative 1 to 1, and it is decreasing between the interval